All right, our next talk will be joining us virtually. It will be Jan from FabuBlox. FabuBlox is a unified process design and collaboration platform connecting the nanofabrication world. Hello, hi Jan, we can see you.
Yeah, yes. Hello, everyone. Great to be here. Can you see me, hear me? Does that all work?
Yes, all good.
Awesome. Yeah. So first of all, thanks a lot for allowing me to be here and this opportunity to speak from the other side of the world. I'm in Boston right now in Eastern time, so it's the evening for me, where it's the morning for you. I'll try to share my slides. Do you still only see me? Because I shared my slides. I'm sharing my screen right now, but I can't tell if it's showing up for you.
No, it is.
All good now.
Oh, there you go. Awesome. Okay, yeah. So to briefly introduce myself, my name is Jan. I'm the co-founder and CEO at FabuBlox. We're a very recent MIT spin-out. I personally just finished my PhD at MIT in electrical engineering. I have a material science background and started FabuBlox with two friends about 2 years ago as a side project. And I'll get a little bit into the introduction of what our motivation was. And a lot of the motivation was honestly my own personal frustration in reinventing the wheel in the clean room. So we thought we can come up with a digital solution that helps us all innovate faster and connect the nanofabrication world.
Sorry, we can't hear you.
Sorry, you can't hear me? Is the audio fine now?
Jan, can you hear me? Oh yeah, sorry.
Yeah, I can.
Oh yeah.
I can. Is the audio fine?
Connection to the speakers in this room, so.
Okay. Is the audio fine now?
On your side, everything's okay. It seems a problem with us, so just give us a second. We're trying to solve the issue.
Okay.
Jan, can you say something, please?
Yeah, can you hear me now? Hello, hello. Test, test.
We can hear you, but it's very, very small and soft.
I can try to move closer to my computer.
No, it's not on your end at all.
Okay.
Oh, I think you're back.
Try it again, please.
Yeah, test, test.
So close. We believe we found a solution. Just give us one more second.
No problem. Just let me know when you're ready.
All good, all good. You're back online. Please continue.
Awesome. So you can hear me now?
Yes, all good. Sorry about that.
Fantastic. All right, so let's try that again. I'm not sure how much you heard of the introduction, but I'll speed it up a little bit in the interest of time. So we're a very recent MIT spin-out. I'm the co-founder and CEO, and I'll introduce the team in the slides in a little bit anyway. So I'll just get started. So what I always found fascinating about the nanofabrication world is that so many of us work together in the same spaces, using the same tools, working on such fundamentally different technologies that really power key industrial sectors and share the set of micro and nanofabrication techniques, but the technological outcomes and products that we make are completely different. And I think that's fascinating and profoundly different from most other industries that the underlying processes that we use and the underlying tools that we use are very much shared, and yet, or maybe because of that, we don't really speak a common language. In other words, the nanofabrication world, in our perspective, has a communication problem, and I'll explain in a second what I mean by that. So a prime example of this is, I always like to start with this fun little example with these speech bubbles, is that shared process databases are oftentimes non-existent or just very limited. So especially in academia, but also beyond academia, we really often rely on tribal knowledge. There's no standardized and unified databases that allow even large companies to store and share and transfer data and knowledge efficiently. And oftentimes, and again, I've experienced this firsthand, even in large companies, what ensues after trying to find out how was something done is this chain of emails where you're like, what steps was I supposed to do? Is there a Google Doc that captured this? Is there an Excel sheet that does this? What do the cross sections look like? Is this version still up to date? And so on and so on. You get the idea. And obviously, this is a very simplified, fun little example. But the overarching message here is that knowledge transfer is just very inefficient in the semiconductor or nanofabrication world in general. The issues that result from that is that we see a lot of reinventing the wheel. So repeat problem solving, I would say, is from the interviews that I've led over the past 2 years with both academia and industry, is that repeat problem solving is one of the biggest problems because of the lack of standardized databases. Likewise, because there's no data standards, lab to fab transitions, so developing something in R&D and transferring that to larger volume manufacturing is extremely challenging. Along the same lines, process interoperability between different fab facilities is challenging, obviously, even within a company that has systems nailed down specifically to their set of tools, but moving between different fabs, if, for example, a tool is down, is extremely difficult, and oftentimes is very difficult to coordinate in terms of respecting, for example, contamination rules and protocols, which then again leads to limited flexibility in any sort of fab coordination. Again, this goes up to the highest levels of industry. I had a very interesting discussion with someone at IBM recently, pointing out exactly this issue with existing systems. And last but not least, the whole technology sector is benefiting from AI, heavily benefiting from AI these days. AI inherently relies on pattern recognition. If you don't have data standards, it's very, very hard to benefit from everything that AI is doing, for example, for software development right now, and we're hoping to change all of that up. So what we developed is a platform that connects the ecosystem in various ways, and I'll speak in the next 30 to 40 minutes about how we're trying to achieve exactly that, and how we're already doing that at this current stage. So the current status quo is really a very disjointed set of tools. When you look at how knowledge databases are built, how process knowledge is shared, how facility infrastructure is managed, there's really two sets of tools. There's one set of tools along the vertical axis. It's very easy to use, highly collaborative tools, but they're just not made for nanofab and therefore lack a lot of efficiency in terms of providing exactly the functionality that we need. On the other hand, and I just listed a few commercial simulation software here that are very good at capturing exactly what nanofabrication processes do and use them for extremely high fidelity simulations. They're excellent tools, but they're very, very hard to learn. They're not made for like very easy everyday usage and for collaboration. And that leaves just a gap that needs to be filled. And we're really looking into filling this gap there with building an intuitive but still purpose-built tool for nanofabrication. To zoom out of that a little bit in terms of providing a higher level vision, what we want to build over the next few years is a marketplace and collaboration platform that automates any nanofab service and asset management, connecting all of the players across the ecosystem, starting from the R&D sector with large volume foundries and tool and material suppliers. For this workshop of particular interest, of course, is a little zoom in into this R&D sector. And I think the ANFF is really at the forefront of a good example there of trying to connect this R&D sector from individual engineers to engineering groups and then also facilities. And if we zoom into this even more, how do we use all of this to connect fab networks and really enhance the fab ecosystem? And the big question is here, how can we use the FabuBlox design and data standard that I'm going to show you in a little bit? How are we going to use all of that to enhance the fab ecosystem? And the answer to that really lies in the slide above. Is we will build a platform that connects the different players across the ecosystem, and that will be powered by what we call the first co-pilot for fab, that will then unlock unprecedented opportunities for automating fab coordination, process discovery, interoperability, and lab to fab transition, and even a marketplace for digital twins. So over the course of this talk, we'll go step by step. This was a jump into the deep end, essentially. But we'll go step by step and first of all introduce the team and where FabuBlox is right now. And then we'll go through these different stages of the R&D ecosystem that I just presented, and how we plan to connect them and how we serve these different needs, starting from an individual contributor or individual engineering perspective, presenting the FabuBlox design platform, how we use this to build shared repositories and build a communication platform on top of this. Then how do we connect this to the real world by integrating facility portals and the real world restrictions and availabilities that come along with facility portals? And of course, very much in the interest of this workshop and the ANFF as a whole, how can we use this knowledge to really supercharge fab networks in terms of sharing knowledge, enabling collaboration, fostering innovation, and improving the nanofabrication ecosystem, where we'll then go full circle to what I just showed, which is the FabuBlox marketplace. So let's start with the introduction of the team and where we're at with FabuBlox at the moment. So the founding team, most of us are from MIT. We have a mix of clean room fabrication engineers and software development team. Josh and I both spent a lot of time over the past 10 years in clean rooms. I have a material science background, but did a PhD in electrical engineering at MIT, and so did Josh. And our CTO, Jack, is a former engineering manager in industry, and Eyal Perry has coded pretty much his entire life and has extensive algorithm engineering experience and is really responsible for all the cross-sectional generations on the fly that you'll see in the following slides in a moment. FabuBlox has gained tremendous traction over the last year and a half because we really, I think, tapped into this need of being exactly in between these two axes of existing tools, and to date have over 1,200 users at over 80 facilities and institutions, most of them academic, but slowly expanding also into the more professional industrial sector, and thereby making up already the largest cross-facility collection of nanofabrication processes that are fully peer created by anyone who's on the platform. We can see here that our users span not just the US. Of course, our majority of user database is based of our user base is in the US, but there's 11 other countries that have a significant amount of users, including Australia. We, I think, have currently about 50 users or so across different facilities in Australia, and in addition to these academic institutions, as I mentioned, there's about 30 plus industry user groups comprising fabless companies, tool vendors, and especially smaller R&D foundries. Last but not least, in terms of giving you a perspective of where we're at, as I mentioned, we are an early stage startup. We received a pre-seed investment from Pillar VC last fall, and are currently building the team and hiring our first employees and building out the platform with this traction that we've gained over the last year and a half. So to show you a little bit of what I've abstractly talked about so far is what does this process design platform actually look like? And I've talked a lot about collaboration and communication and connecting the nanofabrication world. I think the very first and most important thing to mention here is that anything that's documented on FabuBlox is user-owned and facility-owned. It will never leave FabuBlox and will never internally use it in ways that could leak IP, especially when it comes to AI. And this is something that I really cannot stress enough. The modular data standard that we provide, rather than endangering IP, because it is so modular, it really fosters innovation and collaboration while protecting IP, because we've inbuilt a lot of features and continue to expand those to have as fine-grained control as possible to share or even abstract data for given use cases to make sure that only the people that should see your data see exactly the data that you want them to see. Likewise, AI training in the future, we're not at that point yet, but any AI training will only be carried out on public data and will then add on local models to ensure that no IP of any facility or any users will ever be leaked, where the IP could be suggesting anything to users that that is not publicly available. The second most important thing is you can sign up on fabublocks.com at any point in time. This is what our landing page looks like. In the top right, you can just click login, and then it'll redirect you to Auth0, which is an industry standard. Most of you are probably already have user data on Auth0 because, again, it is an industry standard. And we do not store any user data ourselves. And all features are available free to use. And as we are a platform, we will aim to keep for an individual usage as many features for free as we can for the indefinite future. And in the Q&A, I can talk more if there are any questions about our business model. But I think this goes beyond the scope of this talk for now. So going back to where we started from and saying the nanofabrication world needs a common language, we designed a process design UI that was really designed with accessibility, standardization, and automation, especially when it comes to visualization and communication features. And I'll show you what that looks like. So what we did in FabuBlox is that we're, as the name suggests, a blockwise process editor where you see all of the common cleanroom tools, and you also have fabrication modules that you can just populate into a process, and it contains the base level engineering parameters and also the visual information of what this does to your stack. What's cool about this is, and what you're seeing right now in the background is, everything here is algorithmic and on the fly. So any changes that you make to your cross sections, they propagate through. Even if you have a 100-step process, they will propagate through all the way, and there's zero adaptation work to be done. And these are exactly the kind of diagrams that usually for communication purposes we spend a lot of time drawing them in PowerPoint or Illustrator or whatnot, and frankly spend much more time on than we should. But of course, this only serves planning and communication purposes. You hit a wall pretty fast if you want to do more high fidelity process planning and how to adapt your processes to your needs. So for that purpose, we actually joined forces about a year and a half ago with Josh, who built a 2-scale stack simulator, originally for his gallium nitride transistor research, because he was doing a lot of funky fab that some of the existing tools were just not made to simulate. So he built his own algorithms to generate cross sections and then export them into commercial electrical simulation software. And that is exactly what we will be doing as well. So we have a set of features that allows FabuBlox process description to be combined with a mask set and then obtain these 2D 2D simulations that are to scale and use ray tracing simulations and other state-of-the-art algorithms to generate highly accurate output on a 2D cross section. This is just a 3D extrusion, so the simulator is 2D. I'll show you what that looks like in action. So in the process design UI, you can simply upload a GDS file and fetch all of the information that's contained within the GDS file. You can pick a cut line within a selected cell, and then the software will essentially show you what features it extracted across the cut line. And then you do the same thing as you do in the clean room. You literally just assign the layers of the GDS file to your exposure step. Do that for all of the lithography steps in the process. And what FabuBlox then does is it does its magic. It extracts everything from the GDS file, matches it with your with the rest of your flow, and within a minute you get this simulated output that really allows rapid prototyping on a fab scale, where you can explore different design files and process steps very quickly. And the goal of the stack simulator is really to get people 95% of the way there. Of course, this will not compete with a 3D simulator that takes multiple hours to run a similar process. And for the highest levels of fidelity, we will work towards interfacing with some of these commercial tools that do this high fidelity simulation job very well. But again, to get people 95% of the way there and do this rapid prototyping, this is a fantastic tool. And actually, in addition to generating these cross sections for you, we automatically generate slide decks. And I'm showing this just because this is probably our most popular feature. People tell me they haven't touched presentation tools since we've released this feature, because it just populates a slide deck with all of the slides, parameters at each step, and a legend automatically for you, and you can just download it to your computer. I unfortunately swapped two slides here. I was talking about accuracy for a moment, and the one thing that we've learned is that the accuracy of simulations, as with all simulation software, really depends mostly on how well do we know our tools. And what we've learned at MIT and in a lot of different groups using this is that if the stack simulator parameters are tuned well, so you have a well-characterized process, you can actually get quite high accuracy, as is shown in this example of an SEM cross-section compared to the stack simulator output. And using the same tools with these parameters, defining, for example, anisotropy ratios of etches or deposition steps, you can get to high levels of predictability. So this is our base design platform. How do we use this now to build shared repositories and connect the nanofabrication world in a communication platform? So there's one analogy that I always like to draw here, which is the software development world, because what really revolutionized software development is shareable, trackable repositories that can be private, can be publicly shared, but nothing like that exists right now in the nanofabrication world, and FabuBlox is essentially allowing us to catch up. What that looks like in practice is we go to the FabuBase, which is our public peer-created database. You can search, for example, for any material processing step, anything that you're looking for, and we'll find a match for you. To share any process with a private group, meaning building a process repository, it's as easy as going to the share panel, selecting the group that you want to share it with, and it will be shared only with that group and no one else. If you want to keep a process private, no one else will see it. If you want to add collaborators, you can add collaborators that will have edit rights, and you don't have to share it with any group. Again, the sharing possibilities are really as fine-grained as possible, and we're continuing to improve the granularity of that as we go along. The other level of communication that is extremely important is a Stack Overflow equivalent. So what we showed before this is essentially a GitHub equivalent that revolutionized the software development world. But the other thing that not just revolutionized software development world through learning how to troubleshoot, but also in terms of providing training ground for LLMs is Stack Overflow. And the truth is there's no Stack Overflow equivalent in nanofabrication. I always see these online forums where, you know, people say, oh, my liftoff didn't work, or that didn't work, this didn't work, and someone responds. And I always think this is probably not going to help you because they don't know the history of your sample or what's on it or what your process is. Similarly, in software development, if you don't post your code, you're going to get yelled at because no one can really help you, because to understand why a variable or function doesn't work, you need to understand the history of it. And I'm very excited to announce here, and this is a world's first announcement, is that we are about to release the FabuBlox Fabu Forum, where you can essentially ask in blocks and respond in blocks. You see a screenshot of what it will look like in about 2 weeks in the background, and the Fabu Forum will have both public and private forum spaces. It will be automatically linked to private FabuBlox groups, so you can have private forum discussions, but there will also be direct messaging and Slack-like channels for anything that's team or project-based for ongoing discussions. And what it will do is, in this first version, is you can just link it to a FabuBlox process, but in the future, this will be fully seamlessly integrated with a process editor, where, again, as I suggested, you can ask in blocks and interactively respond in blocks to essentially have a process and project-based discussions. What we're missing from all of this is that we've standardized now how you can document processes, but a little bit removed from reality. All of the blocks that we saw in this design platform are very much just templates for tools. They don't represent the full physical reality of what you can do with a tool and also what limitations you have with a tool. The FabuBlox facility portals really aim to standardize exactly that and help facilities, first of all, help their users and maximize their own operational efficiency by enabling more fab coordination and less internal mistakes and downtimes being made, by offering essentially a data standard that not just allows people to document in a standardized way processes, but also standardize how we document tool sets. And part of that will be that you can define tool rules to reduce tool contamination and downtimes with algorithmic rule checks. What's special about this in FabuBlox is that we have information of both the process flow and the process steps, as well as the outcome of the process steps. So we have the visual information and the structural information of your sample seamlessly integrated into our algorithms. So we can even check for highly complex things like, if you don't allow an exposed layer but a buried layer of gold, for example, we can check whether that complies with your contamination rules and thereby really maximize flexibility of what you can run on tools, which right now is just extremely difficult and usually leads to tool downtimes. The other part that we'll add is that you can link tools and process recipes. Right now, these are kind of separate things in FabuBlox where you can save predefined recipes as my blocks, but we're going to link this more into the real world and also allow you to provide design recipe guidelines, essentially allowing any admin to define allowed parameter ranges so that any engineer or in a shared facility, a clean room user knows what ranges they have to move within to be compliant with anything that can be done on the tool, if there's a recipe creation that's not attached to the tool already. And then quite evidently, you can provide shared databases of processes and standard processing modules, which really just takes what we saw in the previous section of this talk to this facility portal level. These portals are expected to become available in April 2025. With anyone who's interested, I'm more than happy to share a demo of what this looks like, and you can email me if you want to be added to our early adopter facility list. These facility portals will be available both for internal usage, but you will also be able to have a public portal where you can share what capabilities are present in your facility. And of course, depending on whether you're an academic facility or on any of the scale towards the high volume manufacturing, you might want to abstract more of this data, but all of it can be fed into where we get to the next and probably most interesting part of this talk from the perspective of the ANFF and the DWL's mission is how can we use all of this to create fab network portals and harness this information to foster innovation, collaboration, and reduce innovation and manufacturing cycles. And the answer to this is that we really have an opportunity here to create a global standard for fab networks, because the ANFF is really leading efforts in terms of how long it's been around in trying to create a fab network. But other continents are aiming in a similar direction, where I'm sure there's a couple of people here that attended the first NanoFab UK meeting last September. The CHIPS and ME Commons Act initiatives very much aim at a similar goal of fostering innovation across the US. And similarly, the Euro Nano Lab in Europe is aiming to build a similar infrastructure. So what we'll do with what I've shown in this talk so far is that we will collect all of these facility portal data and make it available in one central hub, the network portal. And this network portal will allow both users with essentially processing needs and facilities to share their data in a way, once again, that's abstracted in exactly the way that they need to. So an academic facility might want to share what tools they have and even maybe some recipes to really help people put together processes, whereas a large volume manufacturer might just want to share what kind of rules need to be followed that you can actually transfer a process into this facility. For example, for a lab to fab transition, if you're moving from something that was developed academically and now wants to move to large volume manufacturing. This will enable a couple of things beyond the points that we've covered, but really what it comes down to is that you'll be able to find available tools and facilities to match your needs. You can coordinate projects with service providers in our communication portal, and you can even find tool drop-ins for flexible fab coordination. If a tool is down in your facility, you need to find a tool somewhere else. All of that will be also enhanced by our AI features at some point in the future to help with recipe translations between different facilities and between different tools, and to make sure that everything is compliant and gets you to the fab output that you want. Last but not least, and this really just closes the circle of where we started out, is the FabuBlox marketplace. So far we've talked about very much the different players in this R&D sector and how we can connect them and enable collaboration and coordination. But the bigger goal here is really to connect all of the players in the ecosystem, and especially material suppliers and tool manufacturers have shared a lot of interest with us in using this standardized way of sharing recipes to essentially communicate with customers best practices, how to use their materials or tools in a certain way that might also change over time, but also using this communication platform to address any sort of customer service issues on a processing level, and getting firsthand help in a very interactive way, and thereby once again connecting the players across the ecosystem, and doing all of that in an intelligent way, which in the hopefully very near future will be powered by our FabuBlox AI to automate as many things as possible that right now take a lot of time and slow us down in ways that are really not necessary. With that, I'd like to close my talk and thank you a lot for your attention and for the opportunity to speak. We'll also announce a webinar soon and FabuBlox training sessions where we'll essentially train users to contribute to the private DWL FabuBlox group, and we'll take it from there and hopefully be able to contribute to building a collaborative and innovative ecosystem in Australia as well. Thank you very much.